Hello everyone. We are going to continue on probability. Today we are going to look at basic rules of probability. In this session we are going to look at complement rule, addition rule, and multiplication rule. Let's begin with complement rule. So if we have a sample space, say S, and an event in that sample space, E, the complement rule is that probability of the event plus probability of not of that event is equal to 1. So let's make a little diagram to see what we're talking about. Okay, so here is my sample space, and we always represent a sample space by an S, and the graphical representation is a little rectangle. And suppose that there is only one event inside, so the event is E here. This suppose is my E, the event. And if you recall from the probability axioms that the probability of a sample space is 1. Now this sample space is consisting of two parts. One is E, and the other, which I am going to shade in green here, is not E. So this part which I'm shading is not E. Together, E and not E make the sample space. Remember, your sample space is made of E union E complement, or not E. EC is basically E complement. That's what I'm saying here. Okay. Now, we also know that the probability of a sample space is 1. So basically it means that probability, which implies that the probability of S, which is the same as probability of E, okay, you might have to take a little detour here, plus probability of E complement. Now this, remember, is 1, is 1. Okay, so the complement rule says that the probability of E complement is nothing but 1 minus the probability of an event, E. We denote not E by E to the power C, or E with a dash. So let's look at an example. Based on the meteorological records, the probability it will snow in Clarksville, Tennessee on January 14th is 0.236. Find the probability that in a given year it will not snow on January 14th in Clarksville. So remember, not snow. So what is the event we are looking at? The event is there is snow. Okay. And the probability of that snow event is given to be 0.2. Oh, hold on. Okay. 0.236. By complement rule, we want to find probability of no snow. What does that mean? It means probability of E complement, not E, which according to our formula is 1 minus the probability of E. Now, what is 1 minus probability of E? It is 1 minus 0.236. And what is the answer for that? 0. So let's put it in our calculators, and what do we get, guys? 0.764. So here's our answer. So the probability it is not going to snow is equal to 0.764. Now let's continue further. So let me write down here also. This probability is 0.764. Okay, let's look at an example of cash or credit. Now, customers at a certain department store pay for purchases with either cash or one of 4 types of credit. The store records kept for a long period of time indicate that 30% of all purchases are involving cash, 25% is made with store's own credit card, 18% is made with a MasterCard, 15% is made with Visa, and the remaining 12% with American Express. Okay, so this is the information given to us. Let's see what the questions ask. Let the different ways the payment is done at the store be denoted by these events. A is going to be cash payment, B represents the store credit card, C represents MasterCard, D represents Visa, and E represents American Express. We would like to write down the probabilities for all these 5 events. Okay, let's start with this. Probability of A, that means probability of cash payment. Now, when you go back to the problem, it says 30% of purchases involve cash. Now, remember your probabilities are very same to percentages, and they are always a probability lies between 0 and 1. So when you're given a problem where it says 30% is cash, is basically a probability. When you write it down in the formula, you're going to write it as a decimal. So 30% is equal to 0.3. Remember, 30%, guys, is 30 over 100, which is 0.3. So similarly, probability of B, which is the store credit card, is given to be 25%. So you write this as 0.25. Now, probability of C, the MasterCard, which is given to be 18%, you write like 0.18. Now, probability of a Visa card, that is probability of D, is 15%, 0.15. And probability for E, which is American Express, so probability of E is 12%, 0.12. Okay, the next question says, let K represent the event that a randomly selected purchase is made with a nationally distributed credit card. Okay, a nationally distributed credit card, guys. So what are the nationally distributed? There's going to be the MasterCard, the Visa card, and the American Express. So these 3 are our nationally distributed cards. So it means, what is the probability of K? Now, probability of K is nothing but MasterCard. So that means it's probability of C, union probability of D, union probability of E. Now, none of them have anything in common. So it is simply writing it like probability of C plus probability of D plus probability of E. Just put down the numbers, 0.18, 0.12, 15. No, that's 15. 0.12. What do you get the answer to be? 0.45. Okay, the next problem. What is the chance that a randomly selected purchase is not made from a nationally distributed credit card? Now remember, this K is representing a nationally distributed, and not nationally distributed means what? Probability of K complement. which is equal to 1 minus probability of k, which is 1 minus 0.45, which is 0.55. Now we are going to look at addition rules. So in general, for any two events A and B, we have the general addition rule, probability of A union B. Remember union, guys, we talked in our previous lecture. This union, guys, is A or B. That's what it means, probability of A or B. It's probability of A plus probability of B minus probability of A intersection B. So that's the formula we guys have to remember whenever there's a general addition rule. Now, a survey of senior citizens at a doctor's office shows that 52% take blood pressure lowering medication, 43% are taking cholesterol lowering medication, and 5% are taking both the medications. What is the probability that a senior citizen takes either a blood pressure lowering or a cholesterol lowering medication? So that's the example. Now, remember, we will try to write down, abbreviate using simple terms like, let's say, if you take a blood pressure lowering medication, say that represents B. If we are having a cholesterol lowering medication, that can be C. The question says, what is the probability that a senior citizen takes either the blood pressure lowering or cholesterol lowering? Remember, the key point is or. So when you see the word or, that means we're looking at union. And the question is probability. So what we're going to do, probability of B union C here. Now we go ahead and apply the formula. It's probability of B plus probability of C minus probability of B intersection C. Let's go ahead. Now let's look at probability of B. It means how many percentage of those senior citizens at the doctor's office are taking this blood pressure lowering medication? 52%. Remember in the previous example what I said? When you see the word percentages in terms of probability, it is simply writing in decimals. Plus probability C is 43%. That means 0.43. Minus the intersection, that is, they are taking both the medications, that's 5%, minus 0.5. So your answer is 0.95 minus 0.5, which is going to be what? What's 0.95? Oh, 5% is 0.05, guys. 0.05. It's 0.05, sorry. So 0.95 minus 0.05, which is 0.9. Now we're going to talk about a specific event, which is called mutually exclusive or disjoint events. What is mutually exclusive? If I say two events are mutually exclusive, it means they cannot occur at the same time, which simply means that they have nothing in common. These two events do not share any outcomes. And how do you represent? We represent this as probability of A intersection B to be 0. So let's look at a nice little Venn diagram. So if you say two events have nothing in common, no outcomes are being shared. So suppose this is my event A, this is my event B. They have nothing in common. So clearly their intersection is 0. So that's how you represent two mutually exclusive events as a Venn diagram. Now, here are only two of them. Now, if you have many events and all of them are exclusive, Now let's look at this one, E1 to En. So let me just give you a small little diagram for that. Suppose this. So suppose my n, let's say n is 5. So that means I can have an event like this. Say this is E1. I can have an event like this, E2, this E3, E4, and E5. Notice all these events, they together make the whole sample space. But they have nothing in common. That's what is disjoint or mutually exclusive is. So if I take the union of n of these, E1 union E2 union En, then we want to find that they have nothing in common. It's nothing but just adding all their probabilities together. It's probability of E1, probability of E2, and probability of En. Let's look at an example. Now, let's have a sample space S with the numbers 1 till 10. Okay, easy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have an event A, which is 1 to 5. We have an event B, 4, 5, 6, 7, 8. And an event C, 7 and 9. Now let's look at events A and C. A and C have nothing in common. It's 0. So that means when I take the probability, it is 0. If the probability of any two events is 0, that means we say that these events are mutually exclusive. On the other hand, let's look at A and B. Now A and B, if you notice, have 4 and 5 common. So the probability of A and B, remember probability of the event is what? The number of favorable outcomes over total outcomes. So how many are common between A and B? 2. So 2 by 10. So clearly this probability of A and B is not equal to 0, and hence we say A and B are not mutually exclusive. A very important fact, guys. If you say that there are two events, by default they are not mutually exclusive. Until and unless you see the word on the problem mutually exclusive, do not assume that it is mutually exclusive. Very important. So if I say I have two events A and B, by default we'll assume that they are not mutually exclusive until and unless you see the word written in that problem. Be very, very wary of it. Let's look at another example. We're going to take a 3-question pop quiz. Now, we have done a similar problem in our previous video session on set algebras and Venn diagrams and tree diagrams. And we learned how to create a sample space for a 3-question pop quiz. Just to give you an idea, so if you have a 3-question pop quiz, that means you will have, the first question is either correct or incorrect, and then you will have a branch. The second question may be correct, incorrect. Similarly, for incorrect would be either correct, incorrect, and then once again, every third question will be either correct or incorrect. And that's how you go for each one of them. And then to collect the sample space, what you do is you basically go ahead and look at every path starting from the first question. So this is the first question, you get CCC or CCI. That's how we get all these terms in the sample space. Okay, so let's go ahead and look at the questions given to us. Now, what are the possible events here? What are the outcomes in event A if the student answered all the 3 questions correctly? That means it is only triple C. So event A has It is a set consisting of only triple C. Now, what are the outcomes in event B if the student answered exactly 2 questions? Exactly 2. So let's go ahead and mark them. One would be CCI, CIC, and ICC. Let's write them down. B is CCI, CIC, and ICC. Okay. Number 3, problem. What are the outcomes in event C if the students answer exactly 1 question correctly? So that would be 1 question correctly. That would be CII, ICI, IIC. So let's write that down. What is my C? The event C. We had CII, ICI, and IIC. Now, are the events A and B disjoint? Let's look at that. Does A and B have anything common? Nope. So yes, the events are disjoint. What about B and C? Does B and C have anything in common? Nope. So the events are disjoint? Yes. Let's look at the graph of events B and C in terms of Venn diagrams. So clearly, remember, this is the whole sample space. This is my sample space. Triple C, CCI, CIC, ICC, CII, ICI, IIC, and triple R. So clearly, this is event B and this is event C. They have nothing in common. Thank you, guys.